Section 12.2, analyzing arithmetic sequences and series. All right. What makes a now remember, a sequence is just a set of numbers that it's a domain. We put in 1, 2, 3, 4, 5, and then we use a rule and get out numbers. Now, what makes a series or a sequence arithmetic is that the difference of the consecutive terms is constant. This simply means we're adding the same number. All right, so the common difference is what we're going to call D. So what happens is, the first thing I will ask you to do is I will say, well, is this actually an arithmetic series or a sequence? So the way you'll know is, did we add the same number to each consecutive number? So the way you'll do that is you'll simply subtract to see, because I want to know, is the difference of the consecutive terms constant? So you're just going to take 13 minus 7 is 6. 19 minus 13 is 6. 25 minus 19 is 6. So this is the same number over and over and over and over. So yes, this one is arithmetic. Now, if I do the same thing here, negative 4 minus a negative 8 is 4. 0 minus a negative 4 is 4. 6 minus 0 is 6. 12 minus 6 is 6. So we've got a pattern going on. There's a pattern, but it's not an arithmetic sequence. So the answer is no. We don't have the same distance between each term. So it's not arithmetic. Now, if I say, let's see, here we go. There is actually a formula, there is a rule for arithmetic sequences. And that is A sub n, the sequence is the first term plus n minus 1 times the constant difference. All right? So that's where those numbers are coming from. A sub 1 is your first number in your sequence. N is how many numbers are you talking about? Where's the ending? And then D is your common difference. All right. So so first what we're going to do is, if I give you this sequence and you know that it's arithmetic, can you come up with the rule, and then can you come up with the 20th term in this sequence? All right, so here's what you're going to do. We're going to find the rule, and then you can simply use the rule to come up with the 20th term. You don't have to do this 20 times. You could if you wanted to, but I'm going to show you an easy way. Okay, so what we're going to do is this. You're going to fill in the parts that you know, just like in any algebraic anything. So we've got markers everywhere is what we've got. Here's our rule is going to be A sub n equals A sub 1 is the first term. Well, I've got the first term right here, negative 7, plus, and now this is a general rule, so we can just leave the n. Remember, the n is going to match this n. We don't know which one. Later on, it's going to be that 20. We don't know how many terms are in our sequence. It goes on forever. So we're going to leave this n minus 1 times D, which is, remember, the common difference. So we'll have to find the common difference. Negative 10 minus negative 10 minus a negative 7, well, that's negative 3. The negative 13 minus a negative 10, that's negative 3. So negative 3 it is. All right, so that's where we're going to start. And now you know that's not simplified. So this is so you just put the numbers in that you know, and now you simplify that, and that becomes your rule. So now we've got negative 7 plus, and now you've got to distribute this through. So plus becomes minus because it's negative 3. Negative 3n plus 3. So I distributed backwards because I'm taking this times the binomial. And then we're going to combine the like terms. So the negative 7 and positive 3 becomes negative 4. So A sub n equals negative 4 minus 3n is your rule. So that's the first part of your answer. That is the basic, that's the general rule of this entire sequence. So if I want the 20th term, well, that's easy because 20 becomes the n. So I want the 20th term is going to be negative 4 minus 3 times 20. So you multiply that out. Negative 4 minus 3 times 20 is 60. And so negative 64 is a sub 20, the 20th term in your sequence. All right? So what happens, though, if I give you a term and I give you the common difference, but I don't give you the first term? Well, I've given you 2 items, 2 of the 3 unknowns, so you can put the 2 in that you know and solve for the unknown. So let's just put in for a to the 27th, so the 27th term in my list is going to be, we don't know the first term, so that's going to be our unknown, plus n is our 27 right now. 27 minus 1 times d, which is 11. So the trick is simply, as long as I give you 2 of the unknowns, you can solve for the other piece that you don't know, and then we can make it into a generality. So this is the only unknown right now. So let's solve it. Let's say, all right. Oh, actually, you know what? Guess what? A sub 27 is 263. I need a value there, huh? Some of you were saying, how are you going to do that? That's not a real number. There you go. Now you know. All right. So 27 minus 1 is 26. 26 times 11 is 286. All right. So then you're going to subtract the 286 from both sides. And when you do that, negative 23, is that right? Negative 23 is our A sub 1. So now we have the other unknown. This is just a reminder to me. I'll tell you about that in just a minute. So now we can come up here. Now we have the other unknown, so we can plug that into our generality, because the whole point is I wanted a general rule. So the general rule is A sub n equals A sub 1, which is negative 23, plus n minus 1 times my d, which is 11. So now simply do what we did here and simplify, and you'll have your rule. So multiply that through. So negative 23 equals 11n minus 11. Combine like terms. So we have negative 34 equals 11n. There's your general form. Now, in the book, it's asking you to graph these. I'm not going to ask you to graph these at this point. What happens is they want you to see that anytime you graph these that are arithmetic, it's going to be a straight line, and it makes sense because as you go over on the graph, you're going to add the same number each time. So if you go 2 over, you're going to add the same number. So they just wanted you to see that that's a straight line. All right. Now we're getting even more and more and more fun. Check this out. Okay, so so far we've got 2 different types. If I give you the sequence itself, so you have the first term and the distance and the common distance. This type is if I give you 1 term and the common distance, then you can find out the first term. What if I give you just 2 terms and I don't give you either the distance or the first term? Ha 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 ha. Well, in this case, you're going to come up with, oh, this is so fun. You're going to come up with 2 equations with 2 unknowns. You know, you love it. Okay, so what you're going to do is you're going to come up with the first equation is 148 equals, we don't know this one, that's, A1, that's what we want to know, plus, we don't know n, minus 1, and we don't know, oh, wait a minute, whoa. We don't know d. Oh, we do know n, silly. I was going to say we have to know something else. There it is. The n is that part. Okay, so then you're going to put in, then you're going to, and actually let's simplify this a little bit. So 148 equals a sub 1 plus 9d, and we can just change that right in here. Okay, I want to make sure I have enough space. So then we're going to do this one, 556 equals, that's the part we don't know, plus 44 minus 1 is 43. And there's your D. All right. Well, now, when you do this, it's easy to see that, oh, the A1s are going to be the same, so we can use elimination. So what I would do is I would make these numbers are smaller to keep everything positive. I would subtract, so change all these signs and subtract. And when you do this, oh dear, I did it in my notes and I have all these numbers and oh, they're everywhere and this is oh so much fun. Okay, so then you're going to end up with 408 equals 34D, and some of you did that quicker than I could even do it. Okay, so then you're going to divide both sides by 34. So when you divide 408 divided by 34, your common distance is 12. Is that right? Yes, 12. So now you have the D. You can go back into your original or either of your original equations and say, well, now 148 equals, that's the part we don't know, plus 9 times 12. So 148 equals A sub 1 plus, what is that? 90, 108, 918, yes. So subtract 108. Aha. So your first term is 40. Now you have your first term and your distance. So now you can just plug in. A sub n is going to be A sub 1, which is 40, plus n minus 1 times d, which is 12. And now you're almost there. Simplify it. So put that through. So you've got 40 plus 12n minus 12. Subtract the 12 from here. So A sub n equals 30, 28, 38, 35, yes, plus 12n, and you're done. Woohoo! All right. So far, so good. We still have a lot more to go. Oh my goodness. Okay. So now, keep going. Keep going, keep going. So now, of course, to be a series, we've got to add the sum of all of those. We've got to add them all up so we can find those equations. But now once we get the rule, now if we want the sum of the series is simply this equation. All right, this part is really simple. So the sum of the sum of a series is going to be the mean of the first and last number in your series, so that's the mean, times the number of numbers in your series. Okay, so what you're going to do is this. Instead of taking 1 in here and then 2 and then 3 and then 4 all the way up to 28, what we're going to do is this. We're going to take the number in our series, which is 28, times the mean or the average of the first term, which is, if I put 1 in here, so 1 times 4 is 4, 4 minus 2 is 2, plus the last term. The last term is if I put 28 in here. 28 times 4 is what? 28 times 4 is 32, 4, 4, 8, 9, 10, 11, 112. 112 minus 2 is 110. And we're going to take the mean of those. All right, and then when you do that, what I would do, this is, you can add this together and get 112. And then I would just reduce this here by 14 and take 112 times 14. And I did it earlier with a calculator, and you should end up with 1,568. Dun, da, da, da. Okay, all right, so last one, I'm going to do a word problem real quick. Because if you end up with something that says, okay, well, I've got a brick decoration that looks like this. So the first step is I want to know what is the generality of the number of bricks in the nth row. So what I've got is I've got each row has, well, the first row has 1, the second row has 2, the third row has 3. Oh, so A to the n is just n. all right? Whatever row you're in, that's how many bricks you have. So the total number, if the bottom row has 44, the total number of bricks that I need to purchase for this decoration is going to be a summation of 1 to 44. So I've got to have the top row all the way down to row 44, and my general rule is just n. So we just said that the sum of this is going to be the average of the first row, which is 1, plus the last row, which is 44. So the average of that times the number of rows, and we have 44 rows. All right, so we're going to reduce this here and make 22. So 22 times 45 would be 990 bricks that you need for this beautiful decoration that looks very pyramid-like. All right. Whew, that covered a lot. We'll do some together in class. Make sure to ask lots of questions, and I'll see you soon.